Thank you for joining us today for a webinar entitled Advanced Process Controls, How to Squeeze the Most Juice from Your Orange. This topic will investigate how APC can offer a safe, robust and reliable way to realize quick ROI while optimizing operational performance without compromising safety and reliability. My name is Christy Cronje and I'm the marketing specialist for the systems team at Yokogawa Corporation of America. I would like to introduce our presenters today and subject matter experts, Saravanan Prabhakaran and John Williamson. Saravanan began his career as an operations engineer and has operated and optimized almost all types of unit operations in chemical engineering. He has a thorough knowledge of Yokogawa's DCS and NCS in various industries, including offshore, refineries, petrochem, power plants, batch industries, pulp and paper, and dairy industries. His specialities include the industrial automation, real-time optimization, digital transformation, operations management, and dynamic simulation of process plants. John is Shell's process control manager and product manager for Platform for Advanced Control and Estimation, which is Shell's latest APC technology. He has more than 25 years of experience with APC, MPC, and base layer control technologies, both as a practitioner and technology developer. John is a chemical engineering graduate from the University of Florida. Again, welcome and thank you for your interest in APC and your participation in today's webinar. Please remember you can type your questions in the chat box at any time. Right, let's get started. Thank you, John, for joining us today from Shell. We are so pleased to have you here. We wanted to start this webinar by asking you a couple of questions and to give our listeners some insight into Shell's experience with APC and the value that you've gained from this application. Perhaps we can start with this question, John. What were the drivers that made Shell consider implementing an APC in order to solve the challenges that it was facing?
Hi. Shell has been doing this APC ever since the 1970s. We're the originator of the technology back then, and we've been practicing it and leading it ever since. I think Shell has always recognized that there's a certain class of problems that really cannot be solved by normal regulatory control or complex loops, and for that, APC is much better suited. Those types of problems include things that have a really long dead time or very long dynamics, or systems that are highly interactive, where you can't isolate them down to a single 2x2. Shell's focus has always been on solving these types of problems, but solving it in a way that minimizes the efforts to build and maintain these controllers. Perhaps Saravanan, is there anything you'd like to add?
Yes, John, thank you. Good afternoon, everybody. Thank you for joining this webinar. As you are able to see in the bottom of the screen, Yokogawa's brand corporate slogan is Co-Innovating Tomorrow. We partner along with Shell on joint development of APC. We are proud to say that Yokogawa's APC is designed and developed by an end user for an end user to solve any customer problems ranging from upstream, downstream, midstream, etc. On a high level, this solution is basically a DCS system agnostic solution and an industry agnostic solution.
Thank you. John, since implementing APC, Shell has seen some positive results. Can you describe the overall benefits received since implementing the APC technology?
Yes, I can do that. I think you can see on the screen now some published results of how much Shell has made from APC in the past. And you can see it's quite substantial for us. It brings in a lot of monetary benefits for us in terms of improved yields, capacity increase, and even an energy reduction. We even see benefits in things like greenhouse gases. Other benefits are not so tangible, but they're in terms of HSSE and reliability. And these include things like reduced reduced alarm rates, reduced operator interventions. And overall, we get a steadier plant, and we find that leads to higher mechanical reliability as well. So it brings benefits both in tangible and intangible ways.
Thank you, John. To add on to John's point, from Yokogawa side, we have nearly 2,000 applications of Yokogawa's APC running globally successfully. And the figures you are able to see on the screen are basically the officially published benefits from Shell as an end user. This reported benefits constitutes for 25% of Yokogawa's total or global APC applications running.
John, are there any specific reasons why an APC solution would benefit other customers on this webinar?
Yeah, I think it would benefit practically everyone that's involved in a continuous manufacturing process. You know, we apply it in refineries, chemical plants, and in our LNG sites, but I think it's equally applicable to any continuous process. Even pulp and paper, I think, will find benefits from it. You know, the benefits are basically the same in all categories. It's usually in terms of yield or capacity or energy. So those are universal things that drive benefits regardless of the industry you're in. You know, any industry or any application or process where there's more than one possible set of conditions you can operate at, APC can help you find that optimum operating point by first stabilizing the plant and then allowing you to push the plant to the, to that economic optimum. And both we have it and Yokogawa has similar experiences with this.
Thank you, John. The screen you are able to see is basically an officially published achievable benefits in a typical refinery having these major processing units. This is basically published by US Energy Information Administration. But it will be difficult to quantify similar kind of benefits in other kind of industries like a chemical or petrochemical or specialty chemicals, etc. Basically, those industries are having different reaction kinetics, different supply and demand conditions. As a result of that, quantification of benefits as a standard thumb rule will be very difficult. However, we can use this standard thumb rule actually, which is we can apply a 50-40-10 rule, which can be applied for any process industry so that we can quantify the benefits that can be achieved through APC, which is 50% by variability reduction and pushing the plant towards the constraint, 40% by throughput maximization, and 10% by energy consumption reduction. This is just basically a standard thumb rule that applies for any process industry. As mentioned by John earlier, we can have several intangible benefits like improvements in safety, improvements in asset reliability, lesser operator intervention, lesser alarm rates, etc. All these things can be easily achieved by APC, which may be tangible or intangible benefits together.
Thank you, Saravanan. John, what would your advice be to customers on this webinar about implementing an APC? What should they consider before going ahead? What were the lessons learned through this whole exercise?
Well, for us, it's more than an exercise. We live it every day. But, the things we've learned are, we really have to understand what's driving your process. APC is a tool that we implement, but it isn't a magic bullet. You have to understand what your process is, what the drivers are for the process. Once you understand that, APC can be designed to achieve the benefits that you're looking for, to push that plant into the direction that you think is the most optimum. APC can't overcome all the difficulties in the plant. For instance, a base layer system, it is essential that the base layer is operating well before you try and start implementing an APC. It's not a replacement for the base layer. You really have to get it right before you start APC. Build on a good foundation, you'll get a good product in the end. And, the industry has been doing this for 50 years, 40 years now. So it's really a pretty mature technology in terms of work process. And that work process has a lot of steps in it, but they're all important. And I think if you try and shortcut the work process, you will find that you will run into difficulties. So it's well established, it's well known in industry, and you should keep following it. Then I would say that a typical APC project pays out really fast. So you might spend some time up front doing it, but the payout will be either in 6 to 12 months at latest. If you have a good experienced APC engineer leading the project, you'll find that it'll flow smoothly and you'll get benefits in pretty much very quickly. Lastly, I'd say that my advice would be not to discount the time that it will take to maintain after the APC is on. There's a big push when the project's undergoing to, get people and manpower to build the APC, but the real money is made after the APC is on and in keeping it running and keeping it performing day and night. And you should make sure that you have the resources available to keep the APC running at the optimum. Saravanan, any advice you'd like to add?
Yes, I'd like to add a small point onto John's discussions. As suggested by John earlier, he clearly mentioned that a good base layer will act as a strong foundation for achieving good, reliable and repeatable benefits from APC. The figure you are able to see now is basically a typical project life cycle for APC, where end users will be able to achieve benefits by proper base layer tuning, or we used to call as a regulatory control stabilization, coupled with proper design, development, commissioning and tuning of the APC application. These two will definitely generate good benefits for end users on any.
Thank you, John and Saravanan, for your insight. Right, let's hear from Saravanan now as he digs into more detail around APC. Saravanan, I'm going to hand over to you. Thank you.
Thank you, Christy. I welcome you all for this webinar again. I understand we have a wide range of experienced professionals are participating in this webinar. And we frame the agenda as shown in the figure basically to cover the contents in such a way that it is not too generic and not too technical for all the audience who are participating in this webinar. From Yokogawa side, our main mission is to provide solutions to meet and exceed our customer needs. And we welcome any follow-up questions if any additional technical details are required after this webinar. And we'll definitely do the needful so that your conditions or the requirements are met. Let's go on to the technical contents of this presentation. Let's see the typical process control challenges that any end user faces in any industry. Irrespective of any process industry, end users face complex process interactions causing multiple constraints in the plant with very complicated economics, which are very difficult to optimize so that they need to achieve a safe, profitable and reliable operation. So this happens in any industry, whether it is upstream or downstream, midstream, doesn't matter. All end user will face these kind of the process control challenges. Any processing plant will have some kind of DCS, distributed control systems, will be available in any plant. And let's understand the difference between the conventional controls and advanced controls, and why advanced controls are necessary to overcome the challenges we saw earlier so that end users are able to get the desired benefits from operation of the plant. Conventional controls are classic DCS based controls like traditional PID controllers or cascade controls or ratio loops or lead lag. All those things are typical controls that are existing on the DCS. But the main problem with the conventional controls is they are limited in terms of handling interaction between the multivariable process. Many process variables cannot be interactively handled. It will be very difficult to handle long dead time and coordination between the loops. All those things is pretty difficult to handle in a traditional DCS based controls. Whereas all these limitations can be easily overcome with advanced controls. Typically, we end up in CISO system. CISO stands for single input, single output system in a conventional DCS-based controls. Whereas we end up in a MIMO system. MIMO stands for multi-input, multi-output system with advanced controls. Conventional controls helps to reduce the variability of individual loops, just a pressure loop or a temperature loop or level loop, all those, the variability of an individual loop will be able to be reduced, the variability, the standard deviation can be reduced. Whereas with advanced controls, we'll be able to reduce the variability of the entire process or the section of the process, the whole plant itself will be able to reduce the variability using an advanced control. And also, the advanced control will help us to push the plant towards the constraint, basically towards an optimal point. As you're able to see in the bottom figure, Typically, the process will have huge variability as conventional controls cannot handle interaction between the multivariable process. Whereas with an advanced control, the variability will be significantly reduced, which you are able to see in the middle of the figure. And using the optimization function, we will be able to push the plant towards the optimal limit or the constraint so that we will be able to generate the benefits. In a nutshell, APC or advanced controls eliminates the dead time, stabilizes the process, enables the end users to push the plant towards the optimal area. Thereby, we'll be able to see direct dollar benefits as the quantifiable benefits that can be achieved from APC. Speaking on the benefits, this figure clearly shows the cost versus benefit analysis between a conventional control and advanced control. As you're able to see from the figure, just look onto the APC alone. You're able to see the slope of APC for benefits versus cost is very high when compared to the other solutions. Maybe a BLC stands for base layer controls, ERC stands for enhanced regulatory control, RTO is real-time optimizer. Whereas for APC, we are able to see a good benefits. So why advanced process control is required? Advanced process control is basically it's helpful for end users in achieving benefits or improvements in almost all the areas: safety, efficiency, reliability of the asset, reliability of human beings. All those things can be easily achieved using an advanced process control. Earlier we saw some of the typical process control challenges which any end user faces. But this slide you are able to see is basically the challenges faced by end users in choosing the right APC vendor. Whether the package chosen or the vendor chosen is having the solution that is easy to integrate with any DCS system, whether any tools and features are available with the APC software to identify the gaps in the benefits and improve the achieved benefits, whether the APC vendor has the right engineering expertise to safely execute the project, and how costly is the solution to build, run, maintain, etc. So these are some of the typical market challenges which any end user will face before they choose the right APC vendor. Yokogawa and Shell co-innovated and designed the next generation of APC so that end users are able to reduce the total cost of ownership, reduce the engineering efforts for building an APC application, and very easy to sustain the benefits. These were the most important things which Yokogawa and Shell concentrated in developing the next generation of the APC. With Yokogawa's new APC, the end users are able to maximize the benefit with very minimal investment. Oprex is Yokogawa's brand for industrial automation business. And let's see how Yokogawa supports end users to achieve operational excellence in their business. In any operational process, how Yokogawa supports the end users so that they can achieve an excellence in their operation. For any activity to be successful, we need to have 3 P's: people, product, process. We used to call as 3 M's also: man, mission, and method. All these 3 should be in an ideal condition or effective condition. To achieve operational excellence in APC, end users needs to consider whether the vendor selected has the right skilled people with the right product and right methodology available so that they can get the right benefits at the right time. If any one of the things, if you do not have the right people or the right product or the right process, you may end up in getting delayed benefits, or ROI cannot be achieved at the right time. Let's see Yokogawa's quick and fail-safe method of achieving operational excellence. As I told you earlier, Yokogawa has implemented over 2,000 APC applications which are running successfully globally and yielding very good benefits for our end users. Yokogawa was able to achieve this using our proven 5 steps of methodology. The first is the identification, wherein a well-defined methodology will be used to identify whether there is any potential for APC or not. That's the first step. Then once once a potential is identified, the next step is basically evaluation. This is basically an assessment process to identify the gaps between the actual operation of the plant and the theoretical or the expected results. This helps us to calculate the benefits, how much benefit the end users will get, what is the return on investment, all those things. Once an evaluation is completed, the next step is a full-scale implementation, wherein using an ISO work process or anything, the execution or implementation of the project will be taken. Then once a project implementation is completed, the fourth step is estimation, where we'll be able to estimate the achieved benefits after implementation of the APC project. And the last step is sustainability, which is a repeatable tracking process to sustain the quantified benefits so that end users are able to get a repeatable work process to ensure that the benefits achieved are repeatable year over year. Let's see the first step, the identification. All automation vendors deliver automation benchmarking report. This benchmarking report is basically showing a report which shows the effectiveness of automation in terms of alarms, automatic control, or manual intervention, or HMI, MOC, management of change, all those things. Yokogawa has a proven service called CEA, Comparative Effectiveness Analysis. So this service basically delivers in the form of a report with which Yokogawa use effectively for identifying whether there is any potential for APC or not, just by using the report. Let's go more into the details of what is that CEA. So Yokogawa CEA service benchmarks the performance of the automation compared against similar running plants in the world. So basically this report clearly shows the end user what is their as-is condition and the gaps compared to similar running plants in the world. It may be a refinery or petrochemical or specialty chemicals or LNG. So we will be able to compare how a plant A is operating when compared to plant Z in the world, and where the gaps are available, with which Yokogawa effectively uses this service for quick identification of APC potential for any customer. Once the potential for APC is identified, Yokogawa supports the end users in justifying the benefits through a well-defined structured work process by collecting the data, summer data, winter data, low load, high load, all those data we'll be collecting, and interviewing the operations people, interviewing the management people, developing a simulation and quantifying the benefits, how much they will be achieving out of APC. And this helps the end users to prepare a business case for investment justification to their management team. And Yokogawa takes complete ownership in safely executing the project using our well-experienced consultants and engineers, followed by estimation of achieved benefits, how much benefits has been achieved as a part of the execution of the project, and then develop a life cycle program to sustain the achieved benefits in a repeatable fashion. So this is basically Yokogawa's experience, how we were able to achieve success on our projects. Let's see how to count the price of non-conformance in operation of the plant. Yokogawa has a well-proven solution for monitoring the performance of APC on the web in the business domain of the end users. So this solution is basically used for monitoring and analyzing the performance of the plant, which section of the plant is not performing good, which section of the plant is not yielding the desired benefits, how much money the end users are losing by not controlling the process effectively, identify the bad actors, find the root cause for taking quick action so that they can sustain the benefits. And this visualization is available on the web, on the business domain. It can be viewed in mobile devices, and so that the end users will be able to take quick corrective action. And also this is available in different ways actually. You can see the enterprise level performance, individual section level performance, individual asset level performance. You can drill down up to individual assets so that you'll be able to identify the bad actors, or the root cause analysis can be done. KBC, a Yokogawa company, has developed a structured collaborative service called Copilot. By having a digital twin in Yokogawa's private cloud, by collecting the plant and control the performance data, perform automated performance analysis, guiding the plant operations team to sustain the benefits. As you're able to see in the figure, the left-hand side is basically the physical world where the plant operations is carried out with the right economics, with APC in operation mode, operated by operators and maintained or model maintenance done by the engineers. The right side of the figure is basically the digital world where the operation data will be measured in the data center on a private cloud. It may be a Yokogawa private cloud or customer's private cloud, doesn't matter. And then measured using Yokogawa's APC solution and diagnosed whether the performance of the controllers are good or bad. And guidance will be provided by Yokogawa so that the end users are able to take quick actions and achieve and sustain the benefits. So this is basically a service that is provided by Yokogawa and KBC so that end users are able to quickly take corrective actions to sustain the benefits. Let's see Yokogawa's overview of the Yokogawa's APC history over the period of time. Yokogawa is having 20 plus years of strong APC alliance with Shell. And in fact, as John said, Shell are the original inventors of APC technology in the early 1970s and being the leaders of APC in the refining market. As I told you earlier, we have nearly 2,000 applications globally running, successfully giving good benefits for the end users. And our latest and greatest software is called a SPACE, Platform for Advanced Control and Estimation, with which end users are able to achieve proven and sustainable benefits. So in a nutshell, Yokogawa's APC is basically a DCS agnostic, platform independent solution and an industry agnostic. It can be implemented for any industries so that the end users will be able to get the required benefits.
Thank you, Saravanan, for your interesting presentation. Let's go ahead now and get to some of the questions. Thank you to those who have sent their questions through. Saravanan, you'll see some down on the bottom right of your screen. We've received this question. What is the typical time taken to deliver an APC project? Saravanan, can you answer this one?
Yes. The time taken for an APC project basically depends on the scope actually. What is the process we are considering, the complexity of the process, availability of the plant in the desired load, and the base layer controls, how the regulatory controls and the base layer controls are available, whether they are properly tuned, configured. So from Yokogawa's experience, we have commissioned small APC controllers in few weeks and significantly large matrix controllers in few months. So in a nutshell, the time taken depends upon the scope we are considering. So it depends upon the process actually. So it may be few weeks to few months.
John, do you want to add anything?
I think Saravanan covered it well. The only thing I would add is that, regardless of the size of the project that we've done, we usually find the payout is always good.
Okay, thank you. This question's come in. What does a typical APC project cost? Saravanan?
Okay, yeah. Project cost, this is more similar to the time taken for the APC project actually. So the cost of the project is also depends upon the scope we are considering and the process complexities, all those things. So based on Yokogawa's experience, from our experience, we have seen the project is split up as 15% as software and hardware cost, and remaining 85% as engineering services. So that's the typical split up of an APC project. Suppose if the scope is very small, excuse me, if the scope is very small, you will be consuming less engineering services or engineering efforts to complete the project, so that the cost of the APC project will be less. Whereas if it is a large ethylene plant or polypropylene plant, all those things, it's big matrix actually, hot side, cold side, everything will be integrated in one single matrix. So with that being the case, the time taken for execution will be large. At the same time, the software also will be slightly high, so that the cost of the project will be slightly higher. So The project scope directly defines the cost of the project. But from our experience, we were able to see almost all APC projects, we were able to see 6 to 12 months is the typical return on investment for an APC.
Thank you, Saravanan. We've received this other question. In your opinion, how should operators and process engineers be trained to operate and manage an APC application?
Okay.
Saravanan, do you want to?
Process operators and engineers. Okay. As a part of Yokogawa's delivery mechanism, we usually embed the training program as a part of Yokogawa's deliverable. The training will be conducted for operators, how to operate the APC, what they have to do, what they should not do. Do's and don'ts will be properly trained for an operators before we commission the APC as a part of our execution strategy. In addition to that, the engineers, we will be training the engineers on how to use the product. So what are the features that are available in the software to quickly identify the poor performance or where they are not getting the benefits, how to tune the model, how to sustain the benefits will be trained by Yokogawa so that the champion at site who is taking care of the model maintenance or maintaining the APC applications will be trained. So the requirements are basically for a maintenance engineer or a model maintenance engineer, he should have basic knowledge about how a PED controls are performing, basic knowledge about the process, the constraints in the plant, so that they can understand the control concepts along with the process concepts, so that the benefits can be easily achieved and sustained.
Thank you.
Now you want me to add a little here?
Yes, please. Go ahead, John.
So I would say that, when we look at the operator training, I think about it in terms of involving the operation staff in the design of the APC from the start, and get them involved in the project in where they see the problems that need to be solved, what difficulties they have. And as you go through the project, involving them, it'll be more natural for them to progress along with the development of the project, so that by the final phase of the project actually being in front of the operator, him being responsible for it, he feels the ownership. And then as he spends time with the engineer in developing as well as operating during commissioning, he'll become much more comfortable with how it's used and what benefits it can bring. So I'd say we recommend that you really involve the operation staff in the design development, and that would lead to a much better acceptance by him. And similar with the engineer. As a new engineer learning APC for the first time, the best thing the engineer can do is partner with the person developing the engineer and be involved in the project as much as they can, learn while the project's being developed. Knowing, as you get involved, you'll see there's a lot of classroom learning that you can do, but the learning on the job is not, you can't really replace it. And you'll learn a lot that the class will make a lot more sense as you get to experience and ask why things are done this way during the project.
That's great advice. Thank you, John. There's another question that's come through. How much history or data should you have before you try to implement an APC?
From our experience, we usually collect the summer operation data, 2 to 3 months of data, and winter operation data to see the operation variability. That's for the historical data, so that a soft sensor and inferentials can be developed. And in addition to that, when we do the step testing for the APC project, we run the data collector through Yokogawa's APC software itself. It has a high-speed data collection capabilities available. So we use those data, which is run as a part of the step testing, will be used for model identification, data cleaning, and the controller simulation process. So the past historical data, 2 to 3 months of data, is good enough to identify the initial responses between the variables. But during the step testing, we will anyway run the high-speed data collection, which will be used for the data cleaning and model identification process.
So yeah, and the actual step test itself can, again, like Saravanan always alluded to, it depends on the size of the project. Small projects, a step test can be done in a day or two. A large olefin plant, it can be several weeks of testing to get all the data you need. So it really is dependent on the size. And you should also remember that there is a feature called AutoStep that can be used to help you generate the data when it can't be attended all around the clock.
Thank you, John. I think this might be our last question. Does APC benefit a batch process? What are the limitations?
Yes, batch process are nothing but discontinuous continuous process, which is they're operating. They'll be operating few batches as a continuous operation. So once that batch is completed, the next batch will be started actually. So there are several ways of optimizing the batch process. So one way is whenever a particular batch is in running condition, we will be able to optimize the plant operation using APC. And the transition from one batch to another batch, basically, usually it is done by manual operation. So we will be able to provide, Yokogawa provides another solution called Exapilot. With the Exapilot, the transition operation will be optimized so that the intermittent operation will be made as a continuous operation. So when the batch, the recipe is loaded and when the particular batch is in running condition, APC kicks in and it finds a sweet spot and an LP optimization will be done during the normal batch operation. As a part of the batch transition, Exapilot kicks in automatically and then it will do the transition operation in an automated fashion. So with very less manual intervention, we will be able to switch from one recipe to another recipe or one batch to another batch so that the transition time reduces, and once the second batch starts, the APC again kicks in and it finds a sweet spot and an optimization program will kick in. So definitely for a batch process, APC coupled with Exapilot yields very good benefit for end users. John, anything you wanted to add on to this?
Actually, you did a very good job with that, Saravanan. I will leave it at that.
Thank you, John and Saravanan. If any of our customers think of some new questions later, then please contact Saravanan on the email address shown, and he will answer you there. I'd like to thank everyone for joining today, and we hope to see you again on another Yokogawa webinar. Have a good day. Goodbye.
Thank you.
Thanks.